This presentation is about physical factors that affect resistance. So what we are going to learn is how to apply the relationship of the proportionality between the resistance with the length and cross-sectional area of a wire to solve problems. So atong gamiton ang relationship ani nila sa pag-solve og mga problems. Okay, recall again that in the simplest case, rho is not dependent on temperature. Okay, diri sa atong gamiton. And J is simply current per uh, current per area. Okay, and then this potential difference, ang meaning good nimo aning potential difference is equal to electric field times kung unsa ka layo ang imong ang balhinan sa imong charge, no? Ang distance sa imong plus ug sa imong minus. So kung naa kay nga nag-create sa imong electric field. So ang mahitabo ana is your E now, you divide both sides by L. So mabili na lang kay E. So meaning we can express E in terms of that. And this L is the separation distance of the flow from higher to lower potential. A is your cross-sectional area. So what we have now, so gikan ani, we can derive by multiplying both sides by A nga ingon ani dayang expression. Okay? So kato siyang last na to nga nakita is another form of Ohm's law. So katong relationship di ay nga current density is proportional to the electric field, mo din na siya ang gitawag nato og Ohm's law, by the way. So in current density form, pwede po na siya nga napud siya another form, current voltage form, which is nakuha nato kaganina sa ganitong previous nato nga slide. From here, this we define this as our resistance. So this is how we relate a 1 over resistance. So 1 over resistance is A over rho L. Okay? R, therefore, is equal to rho L over A. Get the reciprocal. So, kuha mo reciprocal aning duha. This is it. Okay, so this is the current voltage form. That I is equal to V over R, or this. Okay? So we now have these two forms. Current density form and then current voltage form. Kung asa ang ma-apply na to sa problem, muna na to ang gamiton. Okay? So here, look at this. This is your cross-sectional area, and then so your initial resistance is this. When area is doubled, so what happens if ang cross-sectional area imong dublihan? What does it mean? So when area is doubled, it's like this, no? So gidoble nimo instead of a single cylinder na himo na siyang duha. What happens when the area is doubled? So it's like this. So your new resistance, ang imong final nga resistance now, we will change A instead of just A, we'll change it to 2A because we are doubling the area. So we can extract the 1/2 here. Pareha raman na sila, equal raman. But note that this is your value for katong initial ni mga resistance. Therefore, what we can say is ang final, ang new ni mga resistance karon is just half of the initial, or katong gidoble ni mga area, doubling the area lowers the resistance by half. Natunga na siya. Kung i-increase nimo ang area, mo decrease ang imong resistance. Gi-increase nimo by twice, na decrease ang imong resistance by half. Now, what if we change the length of separation? So initially, mo ni siya imong resistance, okay? Rho L over A. When length is doubled, so ang nahitabo is ilisa na to ang L with 2L. Okay? So ang imong final nga resistance now becomes this. But note that this one is again your value of your initial resistance before doubling the length of separation. So unsay mahitabo kung madouble ang length of separation, so maratag nagpile og duha. So nitaas ang imong length of separation. Okay? So the final now is just twice the initial. So unsa atong ma-conclude from that is doubling the length doubles the resistance. So what can we say? What can we say is that from here, this means that the resistance is directly proportional to length, but inversely proportional to A. Increasing length increases resistance. On the other hand, increasing the area decreases the resistance. That's all.